Yo, what's up, what's up, everybody? Welcome back. Today we are working on replacing Google Maps. And today's topic is to try to render roads and stuff in our map. So, this is what we're working on. This is what we got to yesterday. We pulled a bunch of data from OpenStreetMaps. Let's actually see if we can look at it right now. Let's see. It would be in Res Planet. So, we have this data from OpenStreetMaps at Vancouver. It looks like this. There's a bunch of nodes. And what we've done so far is we've kind of like walked this XML to the point where we pull out the latitude and longitude of all of the nodes in this list, and we render them as points on this picture, which gives us like an approximation of Vancouver. That looks like pretty damn good. But we're missing a lot of data here. We don't have any concept of roads. We don't have any concept of streets. We don't have any concept of like what a street is. And so we need to do that because the point of this project is that Google Maps doesn't know that I have legs, I feel like. So when I ask it, how do I bus from one place to another, it gives me really fucking stupid routes because it doesn't think that I can walk 5 blocks. And so basically every time I use Google Maps, it pisses me off and I want to write something better. So the idea is that I think that all path planning algorithms have to make trade-offs. And so I would like to make a path planning algorithm that takes these trade-offs into account. And so like maybe it will let me tune it for kind of like how I feel on a certain day. Maybe it's like nighttime and I don't want to walk through a sketchy area of town. Maybe I don't feel like walking uphill because I'm tired. Maybe I like prefer walking on bike routes because they're kind of more direct and they're quiet and I don't want to walk on like Granville Street because there's a lot of cars there and I don't want to get hit, right? So the idea is parse the OpenStreetMaps data to the point where we have like useful information, and so that we can do this path planning. And in order to effectively sift through information, I think like graphical display of that stuff is going to be useful. So the plan for today is try to like start working on visualizing, right? So we need to add roads because roads are the important unit of travel. We are going to have to add pan and zoom to this thing because we can't really tell right now what the fuck is going on in here. So it'd be nice to be able to like zoom in and look a little closer at stuff. And then I think that these objects have like properties associated with them, and so it'd be nice to kind of be able to like hover over certain areas in the city and see what properties are associated with them, so that we can get a feel for what types of properties that we will find useful in our path planning algorithm. That's the plan. So add pan zoom, draw lines, highlight line. Perfect. And let's just fucking start moving. Moving and grooving. That's what they always say. It's our motto around here. It's time to move and groove. So, it's fucking stupid. It's actually not our motto. This is the first time I think I've ever said that. But it's the motto now. So the way that we have this set up right now is we are using Zig to kind of like do the logic associated with this thing right now. Right now, that logic is actually pretty straightforward because we kind of just embed all of our map data like directly into Zig, and we just kind of like copy paste that data directly into a WebGL buffer. But eventually this is going to get more complex. So I want to do most of the work in Zigland, but we have to do a little bit of JavaScript because we're using the browser as our GUI. So what I want to do here is I want to add pan and zoom. So we can look at our like vertex shader, i.e. code that runs for each point in the picture that we're trying to draw. This stuff is like basically sorted as latitude and longitude right now. So this is approximately the latitude and longitude of Vancouver. And I'm kind of scaling like the graph to kind of match my expectations of what it should look like a little bit. And we're gonna have to kind of change these things. So what we're gonna want is we're gonna want to have some sort of like concept of how do I want to call this, like zoom level. And this is going to be a float value, and it's going to start at 1.0. And we're going to also have to have some sort of like X offset as well as like Y offset. I don't know where these are going to go right now, but we'll kind of figure it out. Maybe we'll call this like lat center and lon center, i.e. like where do we expect the center of the screen to be in latitude and longitude. I think that makes sense. And then we'll probably, for now, we can probably hard code the XY zoom levels, but maybe we'll want those configurable independently. But for now, we can kind of call it like this. That's fine. So we are going to try to make it so that the center of our screen, position 0, 0, this has to equal lat center, lon center, right? So all we have to do here is just say that these positions are offset by lat center and lon center, like this. And let's just kind of start here. We don't have to get crazy with zoom level first. Let's just start with pan. Pan is simple. It's just you change the value. Where do you get the source of this? Do you own a satellite? No, it's just coming from OpenStreetMaps. We're using the internet's goodwill of crowdsourced data. And for Vancouver, this data is actually, I think, pretty good because I have this friend who's like super, super, super into traffic. Just like weirdly into traffic. And he tells me all about how he's like updating OpenStreetMaps data for Vancouver all the time. So it's actually like very good for me in this project. Okay, what am I looking for? I want to basically set some value. So it's gonna be like GL, what's it called? GL set uniform or something. I probably want like the WebGL version. Let's see if we can find some examples here. So it's just GL uniform 1F. That's what we want. So we want to set some global parameter on our shader. But before we do this, maybe we build and run this thing. I think I have to specify where the data is coming from. Okay, it's gonna take a second the first time to compile, but I think after the first time it's like a lot better. Okay, so we want to go to, I think this now goes to www is where this is living? No. Where is this stuff supposed to live? www is fine. So he's actually probably just mad because I wrote a bug, probably. It's probably that in Vertex GLSL, I probably just fucked up the syntax here. Oh no, is it gonna run this every time? This is gonna be really slow if it does. Okay, an error occurred. Uniform cannot initialize this type of qualifier. Oh, am I not allowed to write equals 1.0? That might be true. Oh, this is really bad. It shouldn't run this every time. That's a real pain, actually. Long center undeclared identifier. Because I call it long center. So this might be a problem with embedding the map data directly in the app, is that like the compile is going to be very slow. Okay, so now it's working, except the lat center and lon center are set to like insane value, like 0, 0 probably by default, which is not where Vancouver is. So we're gonna have to fix that. We are going to have to fix that. So we want to basically call GL uniform 1F, and we're gonna set the value of like the first uniform to whatever the fuck we had it set up before in the shader. So this, and the second one to this. We should look them up by name. We should, but we don't have that capability yet. But we'll get in a second. So let's see. It's like GL uniform. It's like get program parameter. No. GL get uniform location. This is what we want. Which takes in a program and a name. Okay. So we're gonna add GL get uniform location, which takes in a program, which we are calling a I32, and then a name, which we're gonna have to split into two components: a pointer to some U8, like some U8 data, as well as a length for the name name. So we'll kind of slap that in here. You can also set the exact index you want, so you don't have to get them by name. Yeah, do I want to do that? Maybe. Uniform set loc. GL uniform set location. Because if I can do that, then maybe I just don't deal with this. Is this legal? Layout location equals? Layout, what is it? Like layout location equals 0. That's what they said to do. Layout location equals 1. That does feel easier to me, to be honest. Let's just see if that still compiles. Let's see if it's looking about. This is gonna be really annoying. We're gonna have to fix this, but nope, layout syntax error. So WebGL uniform layout. Is this like legal? Is this allowed? Setting uniforms in WebGL. No. Am I stupid? So he sets uniform. Like GLSL set uniform location directly. Like, am I? It does seem like that is what they're saying, but they're just not allowing it, huh? Maybe it's because I don't specify my like GLSL version or something, but it's fine. It's fine. We'll just look it up. Might be a new OpenGL thing. Yeah, I might also just not be using it right, because I think that I'm not even specifying in my shaders like which version I expect to be, so it could be like flagging based off that, but it's fine. It's fine. We'll just do it the right way. Okay, so let me say GL uniform 1F. And what does that take in? GL uniform web GL set uniform. Uniform 1F takes a location and a value. Which is going to be F32, and this returns void. Okay, so now I have to create these bindings on the JavaScript side. So GL uniform 1F is GL uniform 1F bind GL. I'm hoping this takes integers. GL equals good luck. yeah, it sure is. It sure is. Okay, and then we'll say get uniform lock is going to be like get uniform location WASM, which takes in here. It's like the program name len. I guess we don't need to do this. We can just create those parameters as we need them. So like this, version 300 ES would probably do it. I will try that in a second. Because I am curious. But since we're already here, let's make our get uniform lock WASM. We might as well finish this thought while we're here. So this takes in a program, a name, and a name len. So here our programs are in like a global array because they are like WebAssembly objects that are, sorry, they're like JavaScript objects that we can't pass over to the other side, but we can just say programs program. Boom. And then we can say GL get uniform lock. And then we need to convert the name from WebAssembly memory into like a string. So we can just kind of, well, yoink that shit. So we say we're going to look at the memory buffer from name and name len, and then we're going to make a text decoder. And we're going to decode that thing as UTF-8. I think it's text decoder UTF-8. Decode. Yes. So this should be called name. So we'll call this a P. Name pointer. Nape. Nape, they call it. I guess we'll call this like name data. Then we have name, and then we can use name here. And then we might compile and run. We might not. We shall see. Looks like something's probably not working. Layout syntax error, so that's actually, we'd never fix that. While we're here, we can try doing version 300 ES. Let's just see. Let's just see. Okay. Okay, refresh. Attribute, illegal use of reserved keyword. Okay, fuck it. We're just gonna do this. Because I don't know how to fix it. I don't know. Oh, fuck. We want those uniforms still there. We just don't want them. We don't want them to have specified layouts. Argument 1 is not object. Fuck off, man. So we have to do this like stashing of shit here as well. Really? It sucks that like the locations here are going to be like they return a WebGL uniform. Why can't these just be fucking numbers? Note the uniform is compatible with GL int. Can we just fucking pull the int out of here? Please. The following methods are useful. Get uniform location. Like, can I just get the fucking number out? This is so stupid. Extract value of WebGL uniform location. Like, is it really just not? WebGL uniform location to GL uint, or whatever the fuck it's called. To int. Like, I just want... It's an opaque handle. Oh my god. So they're just fucking... Ugh. They're just making our lives so hard. What a pain in my ass. Okay, fine, whatever. It's fine. It's fine, we'll just do the fucking same trick where we say uniforms, uniform locks, and you know, eventually we might have to like give these IDs and like push and pop them, but fuck it. We're just gonna have to make sure that we only call. We're gonna have to be careful about only calling this like once at the beginning, like so that we don't like fucking slam this array just full of shit. But it's okay for now. God, what a pain in my ass, man. Uniform locks push this thing, and then return uniform locks length -1. And then down here, we're gonna have to change this to take in the uniform, the lock, and the value. And then we're gonna have to like fucking look up location. So uniform locks lock GL uniform 1F. I hate it. I hate it, but you gotta do what you gotta do. No active linked program on uniform setter. So let's go look at our index zig, and that is true. That is true, so we're just gonna do it here. And here, we actually have to call get uniform location. The keywords attribute and varying are deprecated in... Oh, use out instead of attribute. Oh, that does sound right. I have never seen attribute before using this MDN tutorial, and then I do see it. Yeah, you know what? Let's try it. Version... GLSL versions. Like, what am I supposed to set this to? Can I actually, like, version 330? And then... Let's see if that's good enough. Out not supported in storage qualifier, only supported in GLSL ES30 and above only. So, okay. So you're supposed to do... I don't remember the difference between, like, ES and non-ES, but I guess we can just hope for the best. Because I remember thinking that, like, ES was, like, a more limited version. Right, I think that, like, it, like, sets different defaults. Does not match fragment shader. Fine. Fine. We'll use them both. We'll use them both if that's what you want. Compiler, asshole. Making me fucking right versions. GL Fray color. Because in this version, I think you're just supposed to like set an output parameter. I think it's like you do this. In this version, we will see. We will see. No precision specified. Oh my god. For float. So it's like what is it? It's like medium P float. Should the A vertex position be in? Oh yeah, it does seem like it should be, huh? That's a really good point as well. It's a very, very good point, actually. No precision specified for float. Really? GLSL, no precision specified. This is what I get for copy pasting from old shit. Okay, let's just do this, I guess. We'll say all floats will be high precision now. Maybe not. Who fucking knows? I don't know what the fuck I'm doing. No precision specified. Why? What do you mean? Do I have to specify it in both here? Do I have to do it here as well? Or is it just confused? Oh yeah, that does it. Okay. Okay. So now let's go back to trying to set the layout. Was it layout location equals 0 like this? Was this what we did? This does, because if I can just specify the locations manually, then I don't have to deal with the fucking caching of layout objects. Only valid on program inputs and outputs. Oh. So maybe I have to go explicit uniform location GLSL ES version. Maybe they don't allow it. I mean, maybe I can just go up to 400 core. Maybe GLSL ES doesn't support it. Uniform location. God damn it, dude. It's so hard to like. It's just so hard. It's just so hard. So uniforms can have their thing directly aside, and I see. Fuck it. We just give up. We give up. And we go back here, and we go back to trying to find the uniform locations manually. So here we have program. We have lawn. What do we call it? Lat center and lawn center. WebGL is only ES as far as I remember. Oh, that's good to know. Thank you. Good to know. You can tell I don't know what the fuck I'm talking about. Okay. Lat and lawn center. Let's see if that fucking solves our problems. Expected 3 arguments, found 2. That's true. So I guess we say lat center key is equal to lat center. And lawn center is lawn center. And then here we say lat center key len. This gets a little ampersand, and this is probably not actually lawn center key pointer, I think. I think these get sentinel terminated slices. Let's see. Please, sir. Please. I am begging you. Get uniform look is not a function. Really? Really? Get uniform location. Fine. Get uniform location. He's gonna be like that. We have to fucking run the server, I guess. That's true. Okay, so that's a good sign. That is a good sign. We are now seeing Vancouver again. Big win for us. And now we're gonna have to like drag it around. Drag it around. So how do we want to do that? So we're gonna have like a canvas drag handler or mouse move handler. On mouse down. Can you do like canvas drag? I can't remember. I think we did this the other day. We couldn't use drag handlers. We had to use mouse down and mouse move. How to write drag event for objects on canvas. Yeah, people are talking about mouse down and mouse up, so fine. Fine. So on mouse down, here we are going to basically call. We're gonna like get the position of the movement. So I think it's like client X and EV client Y, but these have to be offset from like the client bounding rect, if I remember correctly. So we do like minus rect dot left minus rect top, and then we pass these into some function. Except this is on mouse down. I guess we do need to pass in where we click the mouse, because that's going to be kind of like the drag start position. Then as we move, we're going to set the new position relative to that drag position. So we're going to say like, let's see, what is this thing called? What do we call it? Mod instance exports mouse down with this. Okay. Yep. Then we're going to do a mouse move. Or, okay. We're going to do on mouse up. We are going to, I guess, mouse up. And then on mouse move, we're going to do basically this. Okay. Now, I'm going to be really pissed off by this compiler stuff. So we're going to take a break on this. And we're going to try to do a fix compile speed. Because I'm going to lose my fucking mind. So I suspect that if we make a WebAssembly library that we link against, I wonder if that will be better. Can we do like zig? Well, okay, first let's just see what happens if let me just make sure that if I arm-r zig cache, I just want to make sure that like doing that there's not like something fucked up in my cache that's causing it to recompile this thing over and over again. What do I call it? The like map data. So just to like explain the problem to you guys, we are taking the map data and generating this zig file out of it. My fucking editor is fucking losing his mind. Fuck. We'll try again. So if we just go to like here, this is like a zig file, and every time I edit like my index zig, it feels like it has to reprocess this file, and it's like expensive for him to do that. So I'm kind of hoping that there's some way for me to like factor it out into like a library that we link or something so that it doesn't fucking take so long every time. So let's see here. So we could do something like, if we were to make a static library, well, I could do zig static libraries. How large is that final battery? Like big. Like big. 25 megs. I think that there's a way. Well, let's just try doing whatever the build script has for like library generation. So we're gonna say like we have a self b add static library. Okay. And this is gonna be like, we're gonna have some options on here. We're gonna take the root source file and we're gonna give it a name. Those two things seem reasonable. Okay, so we have like name is map data. That's tiny. 25 megs. It feels big. Am I crazy? And there's gonna be self b path of oh, this actually goes up here. This goes up here. So this, here we go. So this stuff goes away. We run our preprocessor generator data, and then we say this is the map zig is this. Then we can say that the root source file is map zig. Okay, and then we need target on here, so we just kind of say here's our target, and our it probably needs opt as well. No, he's chilling. Yeah, optimize is equal to self opt, and then this is going to return a compile thing. Okay, so I'm hoping that now we can take in a compile step here. And here we should be able to like link library. Uh-huh. But then like, doesn't he need like, where does he get like the imports from? Zig link library. Do I just, hello, you're gonna need to export stuff now in mapzig, right? Is that how it works? Like, is the static executable generated by Zig not something that I can like get like handles to? I guess we could like assume that those things are exported. So we could do like when we pre-process the data, if we do like pub export const, then we can like write a header that expects these things to be exported. I don't really know how like Zig libraries work. But we could do maybe. So these maybe have to be exported as like usizes. And then here are points. Yeah, I don't really know. Zig export. Yeah, I guess we probably just have to go through CAPI, huh? Stupid question. Why aren't we putting the data in a data format that can be loaded by the program? That isn't a stupid question. I think we should do that. But we just generated Zig code the other day because it felt easier. But now I feel like it's not easier. Now I'm starting to feel like it's not easier. So because like also this will be a pain in the ass forever, because if we want to like ship updates to like the code, it will have to require a full redownload of all the data. So I think maybe you're pointing out a valid concern, and maybe we should just serialize the data less. Like, it was kind of like a fun way to do it initially, but maybe we just don't do that. Maybe instead we just write these things like at the beginning of the file, then do the rest after. Seems reasonable to me, maybe. The problem here is that we want like the minimum maximum values to be stored at the beginning of the file, probably. If we're gonna do like binary format, yeah, I agree. Making JSON or something and loading at runtime would be easier now. Say we just want to get crazy and do binary format. Do we want to do that? No. Sorry, thinking. No, JSON's fine. JSON's fine. Fuck it. Fuck it. We'll make a little JSON. We'll make a little JSON. So here, our JSON writer is going to be like stood JSON write stream around stood out writer. And he's gonna have some options, but I don't really give a shit about them. Maybe I do care a little bit about them. What are my options here? We're gonna have emit strings as arrays in white space. Fuck it, that's fine. It's fine, we'll figure it out. We'll leave it empty for now. Now we are going to start by saying JSON writer begin object. We are going to I guess initially we're going to set the indent level so that I can open it in an editor without like fucking crashing. So we're going to call this like indent 2 or something. I don't know. We'll see in a second. Is that what this is? Write stream white space indent 2. There we go. Then here we're going to go like JSON writer begin object key field. So this is going to be points. Object field points. And he is going to say now that we are writing an array, baby. We are writing an array. Then here, when we run through the XML, we're going to be doing a stood JSON write stream is what is going to come here. And he's going to, I think, just wrap an AnyWriter. I guess this write stream function is going to return some type that we can write down. So this returns this, I guess. And I guess we just have to write that down, which is a little annoying. A little annoying, but we'll live. And this is probably going to be a pointer to the writer, to be honest. Okay. So then we have our writer that we are ready to write with. And this just takes in the JSON writer like this. Chillin'. Then on each of these things, instead of just fucking dumping out the values like this, actually, we probably still can just dump out the values like this, which is kind of funny. But instead, we'll just call write, I think, is the thing. We can just write lawn like this, I think is what it lets us do. And lat. Maybe we'll write unreachable here. This will just crash the program if they fail to write. To be honest. Then what? Then at the end of this, we just end the array. And then we add our object fields for the other things in here. So we had min lat, max lat, and then min and max lawn. Then we end the object. And here we just say write. We need to write the user data min lat, max lat, max lawn, and min lawn. All right. We'll see how fucked up that is, but it should be fine. Do I have to defer JSON writer dot like end or something? No, I think it's probably fine. so this is going to fail to compile in all sorts of ways after this thing is generated, but maybe we'll see something insane. Fuck! Expected type that found const. Okay, fine. Fine. You want me to fucking make my thing mutable? I'll make it mutable. Little bitch. Why is he so... Compiler is always so rude to me. He's always like, could you write the right code, please? And it's like, come on, man. Just let me do what I want. Let me do what I want. In all honesty, I'm very thankful that he yells at me because in language really don't yell at me, it's so much worse. Holy shit. Okay, let's like look at what this thing generated. Fuck. I shouldn't have done that. Opening the thing in Vim is like just mental. Instead, we should open it with jq dot this. Can I like... What the fuck is going on, Vim? So it looks like JQ parsed that thing fine. And let's just kind of like kill dash not. Holy shit, NeoVim. Using fucking 30% of my RAM? What the fuck are you doing? Get the fuck out of here. Okay. Also, how big is this thing? 157 megs? That's crazy. That's wild. So I think probably it'll make sense eventually to strip this down into a like better file. But this will solve our problems for now. I hope. We will see. We will see. We will see. So here, instead of installing this thing as a library, we are going to say this is JSON. And we're going to install this to somewhere. Instead of adding this static library, we're going to say self b install bin file. We'll call it a bin file. It's not really a bin file, but that's okay. What is the arguments this thing? Source path, des path. It's like maybe like install artifact is probably more what I want. Install... Is there no like install lazy path? Like... Oh, install file. Add install file. What the fuck? So how come this does not take in a lazy path? Oh, he just assumes it's relative, which is not what I want. Okay, so we want to do it like an add install file. And we take in the map zig. And this is not zig, this is now map JSON. And we install this to somewhere, probably. What does this guy take? Just a des path. Sure, so we'll just install him to like bin map data JSON. And then we say, so this is the install JSON step. And then we have like get install step depend on install JSON step dot step. Perfect. Perfect. Okay, so now this guy doesn't require this. He doesn't link this shit. And he doesn't take in anything here. And this doesn't return anything. Okay, let's just see how fucked up this is. Let's see. We should see at the end of this. So this is correctly crashing because he's like, what the fuck? That doesn't exist. Which is just true. We do have map data JSON here, which is a 164 meg JSON file. So that's good. And then in here, we can just say ln-s zig out bin map data JSON here. Okay. So now we should be able to just kind of like load that shit. Eventually. Let's go on to the other side here. And we will go into our index zig. And here's what we're going to do. We're going to make a function like push data. Yes. Yes, push data. So this is going to take in like a chunk of that JSON data, right? Which is going to be maybe a pointer to some U8 data as well as length. Okay? We're going to have a global variable. Don't yell at me. Don't yell at me. Just you can yell a little bit, just a little bit. And we're gonna call this like map data. And there's gonna be an array list of U8. Initialized with the heap WASM allocator. I don't know if I'm allowed to do this here. We don't have stood. That's crazy. We made it this far without it. Okay, so now when we get some data, we're gonna say map data push slice append slice chunk from 0 to len. Okay. Let me think about this for a second. I'm thinking. So this stuff has to come from WebAssembly, like the JavaScript side has to like give us he has to have this stuff in memory somewhere. So we're also gonna have to say like, whoa, what is up, everybody? Typecraft, what is up? Hello, all of you guys. Look at all you guys sending nice messages. You all have to say hello. You guys have been trained well by your parents. Because when I go places, I just sit there quietly and hope somebody will talk to me. Right? You just kind of like go there and you stand in the corner. But you guys are all taking the initiative to say hello like good citizens. So hello, welcome. I don't know if I have something to show you right now. We do. Okay. So we are working on a map. This is a map of Vancouver. It's pretty poorly stretched and stuff right now because we're just kind of like randomly guessing how latitude and longitude map to image space, but we're getting somewhere. So the idea is that when I use Google Maps, it pisses me the fuck off, right? I go, hey, Google Maps, say I'm like over here in Vancouver, by the beach, right? And I want to go downtown. And he thinks that my legs are too weak and small to walk like 5 blocks, 10 blocks to the fast bus on Broadway, which would take me to the train, and then I could take the train downtown. He says, no, we will only walk 3 blocks, and we will wait for the number 4 or the number 7. And those buses suck fat dong. They are the worst. They come like, sometimes they just don't come for like an hour. And then you're like, well, I could have just walked 10 blocks and I could have got there, half an hour earlier, right? So I want to basically pull transit data for my city and figure out kind of like the consistency of buses as well as like the frequency stuff, like look at their schedules, look at their consistency, stuff like that, and use that plus like heuristics on map street data, right? I don't want to walk uphill. I don't want to walk on a busy street. I'd prefer to I think that I can walk relatively fast relative to a normal person, stuff like that, right? I want to be able to like punch in all this stuff about what I prefer, and then it can tell me a schedule that I want. So that's kind of the goal, and we're gonna make like some sort of like complex path planner that has a bunch of tunables. We're on day 2, so we're kind of just working on right now, kind of scraping data from OpenStreetMaps to try to get like some semblance of what the fuck is going on in the city. And so today, what we were trying to do is we were starting on kind of rendering roads. So what we're seeing here is actually only intersections being logged or points on the map, essentially. Like basically, like if you were to draw a road, you would draw it like this, right? Boom, boom. You would draw like, you'd mark a spot here, you'd mark a spot here, and drop between them. We are not showing any lines. We are only showing points. So we were working on rendering lines, but to see the lines, we have to be able to zoom in. So we're working on zooming in, and all of this data is just like embedded in a Zig source file right now, which is fucking stupid. So every time we compile, it takes like fucking forever. So now we're sidetracked on trying to fix that, splitting that stuff out into a data file that's loaded at runtime. And that's when you guys came in. So, hello. Welcome. I hope that is interesting. I hope you guys had fun wherever you came from at Typecraft Stream. I hope you guys were enjoying yourselves, but we have to get back to it. We have to nose to the grindstone, guys. Nose to the grindstone. Okay, so we have a JSON file that we're going to be loading from like JavaScript land, right? We're going to say, hey, I would like to fetch this fucking 150 megabyte file, please. And so we're going to like push that in sections into Zigland so that we can parse it. So we have this like map data that's going to be like kind of the whole thing. We're also going to have like chunk, which I guess we're just going to say is like a global variable that's like kind of like, 4K large. That's right. And we can probably like export this thing as well. So we're going to say like, pub export variable chunk undefined. So we're gonna call this like a global chunk. And what we are going to do here is in JavaScript, we are going to try to get like a streaming reference to the JSON and basically like stick it in global chunk over and over again, then call push data with this chunk address and however much data is actually in there. And then we append that to this stuff, and then when we're ready, then we can call run, and he's going to parse the data to map data. That's kind of the vision right now. Who knows if we're going to get there, but we'll see, we'll see. Okay, so somewhere, somebody is going to have to be like, bitch, I want some data. So he's going to call fetch, and he's going to be like, could I get, what is it called? Map data? What do we call it? Map data, yeah. Please, could I get map data JSON? Please, sir. And we're going to like await that to get the header. And then we're going to say, I think it was like reader when we looked at this last time. Body reader, array buffer, streaming body fetch. Surely this will give me what I want. Streaming request of the fetch API. Response body get reader. Okay. And is this like awaitable? This gives me a readable stream, which doesn't sound like a promise to me. So we'll say like while true, I guess we'll just copy this. While true, we do something. We get some shit from the reader, and if it's done, we break. Otherwise, we shove that shit into our WebAssembly, which means that this kind of has to come after our WebAssembly has been instantiated. So we're gonna like kind of shove this down here. This has to be probably after we've assigned a memory too. And we're gonna be like, hey, I want the global value of, what do we call it? Chunk? Global chunk. And we're like, hey, I want to look at that value in the memory. So I guess we know that the chunk is 4096, so we're not worried too much about that. And we're going to do like, thinking. I don't really know what value here is or what global chunk is. I expect that this is going to be a pointer into WebAssembly memory. So we should be able to do like memory buffer. We're going to like new u int 8 array looking at the memory buffer from, fuck. Oops, I hate it when I accidentally type a fucking number. From this with length of 4096. So this is probably fine. So we're going to call this like chunk buff. Then we're going to like chunk buff set value. And then we're going to have to do something tricky like basically iterate however much stuff is in here. And I don't really know what that is yet. So instead of doing this, let's just write this received value that they wrote. And break immediately. We're only going to look at this once because I don't really feel like doing this over and over again. So can we like, of course the builds doesn't work right now, which is kind of expected, but I guess we have to make this thing compile at least a little bit. So this needs to catch unreachable, and then points doesn't exist. So we're just going to kind of comment out everything. Yeah, fuck it. We just compile out everything in the fucking world. There we go. Okay, refresh. What do we get? Baby. Move mouse is not a function. Fuck off. We have other hand. This is what we get for not finishing any individual step of development. Refresh. Okay, we received this shit. So we received like a 260k chunk of this. So we're gonna have to, this is a uint 8 array, which is kind of nice for us, to be honest. So we basically just in 4k chunks, copy that shit into WebAssembly memory and then push it. Does it make sense for us to like allow this to be way fucking bigger? 4k seems fine to me. 4k seems fine. Actually, in data reader, can I ask for 4k chunks? That would be even cooler. That'd be way cooler. Then I wouldn't have to do anything myself, and we wouldn't have to think. Okay, this fuck you. I searched a fucking API name with camel case, and you give me get Adobe Reader? God damn it, dude. Fine, we'll fucking type JavaScript. Like, okay, so can I like read with a specific length? Because that would be so cool. That would make me so happy. Get reader options mode. Whoa! Bring your own buffer? This seems awesome. Wait, let's just do that. That sounds fucking sick. I would love to bring my own buffer. Because then I can just read just like fucking straight into WASM memory, and then there's no copying. What is like the type of BWAB? Can I just say like my BWAB is this? Like chunk buff is this, this, this. And then can we get reader with BWAB of chunk buff? And then all we have to do here is when we push data, we can just say, we don't even have to give it the chunk, we just say the length. Right? And then here we do like, we'll let him think for a second. You know, we'll. Okay, so this received an array that was very large, which is a little concerning. Which kind of makes me think that the BWAB isn't working. Because it needs mode. Okay. So here it's not, we did this wrong. This does not take in this. This takes in mode of BWAB. And then here it must be that when we call read, we probably have to pass in the buffer on read or something. Certainly. Yeah, sure. So this, we're gonna read into chunk buff. And then we have to actually be careful here because I was gonna say like the memory can like move, and it can move, yeah. So if we like allocate too much memory from the WASM side, it might reallocate the whole memory buffer. So we actually have to do this on every iteration here, which is fine. It's not the end of the world. And then what does this fucking thing return? It returns a promise, which fulfills or rejects with a type, and value is the chunk. So then we just pass in here like the chunk length. So we just say, hey, we got some fucking shit. Could we call mod instance exports push data of value length? Probably byte length is like a little bit more correct, but it probably doesn't matter here because they're the same, but we'll see. I guess here we'll write byte length here as well. Let's just see. Let's just see. We're not running a web server, so cannot transfer. What the fuck? Where is this? Cannot transfer ASM.js array buffer. God damn it! He had me so excited. He had me so excited. Read. Can we like WASM? I don't think. This isn't what I want. This is not what I want. So who? Let's like try to figure out console log chunk buff. Like, we're not fucking stupid, are we? Okay, we are stupid there because we didn't type console right. It's a hard life out here. It's a hard not life. Okay. Then can we pause on exceptions? Hello, there we go. Perfect. So this is a thing. Is it that the read call is not supposed to? Like, if we just like give it our own. Like, is there an example somewhere? Here we go. Okay, a function that uses reader calls read method recursively. The method takes a uint to iterate typed away, blah, blah, blah. Yeah, so I don't really see why this isn't allowed. It must just be that that error that said, I can't fucking use WASM, likely means that he can't use WASM. Right? There's a real good chance. A real good chance that's a problem. Can we just see what this says? What does this even mean? I feel like mental. Can we... It is here. This is the read. Okay, so let's just... can we, like, new uint8 array... Like, how do I make this thing... Like, if I try to make this thing out of an array buffer like they did, does that work? Because if that works, then we're using the API correctly, and it's just, you know, fucked. So here we can do, like, read new uint8 array around array buff. Like, if this works, then it just means that, yeah, okay. So we're just, like, literally not allowed. We're just not allowed. Okay, so that's fine, though. That's fine. We will still just, at least by doing it in 4K chunks like this, we still are, like, limiting the amount, which makes this a lot easier, right? Because now we can just say, hey, chunk buff set, I guess we'll say, array buff, or uint8 view is this shit, right? And then we can set this to value. Oh, I guess we can just set it to value. Yeah. And then here we say push data. Mod instance exports push data of length value length. Yeah, maybe. We'll kind of see what that looks like. It might work. It might not, but it might. Fuck. Attempting to access detached array buffer. What the fuck does that mean? What the fuck is a detached array buffer? Why? New array buffer. What the fuck? Oh, maybe we have to make a new buffer every time. It's possible. Possible. Looks like it's not mad. Am I like fucking cranking memory? Yes, but I don't know. Dude, that's crazy. Dude, that's not good. Oh, that's actually not too bad. Does it like fix itself? Oh, we are actually we do actually use all of that memory in WASM land. So maybe that's fine. That it is still actually kind of like pinned over there, so it kind of makes sense. Okay, maybe that's fine. Maybe it's fine. Is that buffer lost because it's not pinned for threading? What the fuck does that mean? Pinned buffer JavaScript. What the fuck does that mean? Array buffers can be transferred between different execution contexts. Detached, max byte length, resizable. Can we actually just go back to the BYOB example? Like, what do these guys do? Because I just assume that you can reuse the fucking same buffer. So they have a buffer somewhere that they're just reading into this. which seems like it should be fine. Yeah, I don't really see a problem here. So here they say, hey, let's make a buffer here, right? Then they say, hey, for each of these things, I'm gonna do this. So what the fuck is the problem? What the fuck is the problem? I'm down to try again and try to figure it out. Okay. The second iteration loop problem happens, I think. Yeah, I agree, but I don't understand why it's like totally fine for them in their example. You know? They assign buffer equals value dot buffer a little bit down. Oh. So they like we send it off and then we get it back. Ah, okay. Good eye, good eye. Thank you for that. So here we go. Array buff equals value buffer. Very strange. But sure. So there's some sort of like execution content. We like pass it over to one side of things and we get it back on the other side. So this is to be let now. Okay, so that looks like it fucking compiled and ran. I guess there's no compilation in this world, but that feels better to me. That feels much better. Okay. So we should fucking have, please, God, we should have like the whole JavaScript in WebAssembly land. And we can check that by making a function log. And he's going to take in a string and a length. And let's maybe just print out like the first like 1,000 characters of it or something. So we're going to look at like memory buffer. We're going to look at like a uint array view into this memory buffer from s to len. We have like buff is this thing, and then we have our like new text decoder UTF-8 decode buff, and then we console log that. Okay, so then we pass log wasm over to our wasm execution context. And then in index zig, we should be able to say like we have some extern function log wasm who takes in a uint8 pointer as well as a length and does nothing with it. And then after all of this, we can say log wasm from map data items pointer from, and we'll just log like 1,000 characters. Let's see. Nothing happened. Do we call the run function? We do. So it's possible that is this even running? Hi, mom. Oh, it was running. It just took a while to get the data. Like a really long time to get the data. like a really long time to get the data. But it does look like we have the JavaScript over there, which is great for us. Holy fuck. So here we can like, that's crazy. Is it just because this is like way too small? Do we just have to make our buffer like does this go way faster if we make this way bigger? I have no idea. 1 Mississippi 2. 1 Mississippi 2 Mississippi 3 Mississippi, but it compiles faster. Yeah, this doesn't solve our fucking problem, huh? But can it be cached? No. Can I force it to be cached? Why is all of this stuff cached, but this isn't? Also, why is this so... I guess it is just really, like, a lot of data. One Mississippi, two Mississippi. Yeah, this sucks. This all sucks. What if we gzip it? Is that faster? Is that legal? Can we do that? I guess 4 seconds is maybe... No, it's not okay. It's not reasonable. It's not reasonable. And it's just because, like, the fucking size of this thing is bloated up to the fucking moon because of, yeah, it's just got, like, really fucking bloated. Because, like, this was... How big was this in binary? Like, 25 megs? And it's going up to 160? So maybe we just, we go a second route. Hear me out, hear me out, hear me out, hear me out. Hear me out. We go back. We go back, baby. And when we pre-process the data, we write this stuff to JSON, but we'll just fucking write the actual point data just as like raw fucking little Indian float 32s, baby. Fuck that shit. So here we're gonna have to specify that we have like a specific output thing. Yeah, I feel like that's like a kind of like nice balance of both worlds. We can have the data itself just blob, everything else metadata in JSON. So that means that we're gonna have to change our little preprocessor script to take in like a file. Oh, we already do. We have an out file. Look at us. We called it stood out writer because it used to go to standard out, but now it doesn't. So we're just gonna say we're gonna have like an out file here at 2, and we'll call this anywhere that says standard out right now, we'll call this binary out, or maybe we'll call it points out. Okay, chillin'. Then the we'll have a second file that's like metadata out. Metadata out file, and this is gonna be args3. Bing, bang, boom. Okay. Are you streaming the file? I think so. I think so. I guess it kind of depends what you mean, but I think so. So this is now going to, the JSON writer is the around metadata out file. Okay, but the points out writer now is just yeah, okay. So we get points out. This is metadata out, which actually doesn't have to be passed into user data at all. So we'll kind of just delete this. And we have points out, which is just a stood IO any writer. Boom. Now over here, we go fuck this. Points out right. Oh, maybe this is fine actually. Stood mem as bytes this thing. Yep. Okay, and I guess we can like stood debug assert that built in like that we're little Indian, which I think comes from here. No, there's like a stood something to native. How does this figure out? Native Indian. Where does this come from? Built-in CPU arch. Okay, we were close. So we just assert that we're little, and then I don't have to think about like big to like when whatever. Just don't have to think about it. Just don't have to think about it. Okay, then at the end of all of this, so points out writer goes to our user data to points out writer. And then our JSON writer, we don't have to do anything till the very end. After we fucking rip it to the end of time, after we've gone through the whole file, we can now just say, fuck this points field, but everything else stays the same. And then in our build zig, now we just have to make it so that when we run this thing, we have the add output file bin. So this is the points data. And then we also have a metadata. Yes. Metadata. And then we install both of these things. Yes. We have points data. He goes to map data bin. And then we have the metadata goes to metadata.json. It's all coming together. It's all coming together. Which we also have to install. So install. This is actually not install JSON. This is like install bin. And then this one is install JSON. And then this goes here and this goes here. And we have install JSON step. Boom. I think that all makes sense. This gets from metadata. Is this right? So we... Yeah. Yeah, that looks right. It's not guaranteed to be wrong. Not guaranteed to be wrong. Fuck! Pre-processed data, 87. So... points out writer. Oh, is this not ampersand? That's probably why. Write. This needs to be write all because I don't want it to ever fail. And then has no member named error. I probably just fucked this up. Out f metadata out f. What is? Yeah, okay. So here we get the metadata out file. This is the metadata. Yeah, it's fine. Then just down here, I think we have to write writer. I think that's the fix. Okay. Okay. Maybe. Maybe. So now we have a 25 megabyte bin file as well as a fucking small JSON file. Let's fucking go, baby. Let's go. And then here we say, we link from zigout bin map data bin to here. Okay. Much better. Okay. So now we're going to go back into, what are we looking for? Okay. So when we, in our index.js, when we fetch all of this data now from here, it's not going to be the JSON's problem. It's map data bin. Okay, big win for us. So now when all is said and done, we should have like a fuck ton of float32 data just sitting in here. Which is really good. Okay, so if I refresh right now, well, that fucking came in at a reasonable pace. Really big win for us. And I think that the way it is right now, we can actually start rendering the map again. Because we're actually not using that metadata at all right now in our code. We're just kind of have it hard-coded. So I think that here, instead of the points here, we just bind 32-bit float data from our global map data. So I think it's like this. Fuck! Right, so here we actually have to do like, const map data f32 is going to be like map data items, and we're going to do like std mem slice or bytes to as slice of f32 like this. And then this stuff just kind of comes with for 3, I think. Like this. Maybe? I don't know. Not quite, because he doesn't like found align 1. Oh, can we just align cast this? Maybe. Might be fine, might not, but maybe it is. Might work. Then vertex count here is at 53. This is now map data F32, points line over 2, and no points, just line. Vertex count is expected I32, found U size. Oh, because this used to be comp time int. Okay, so now we actually have to cast it. That's fine. Doesn't fucking matter. Let's fucking go, baby! Recompile speed is now... Oh, that's gonna... Oh, fuck yeah, okay. That was a worthwhile detour. A long detour, but a worthwhile one. So we're back on panning and zooming. That was an hour-long detour, but holy fuck, that was gonna suck. So, big win, big win, big win. Now we can finally fucking iterate on this without losing our goddamn mind. Okay, back to on-mouse move stuff. So, let's add an on-mouse down button function. So, pub, export function, mouse down. And, what are we doing here? We take in the X pix and Y pix. Let's think about this a little bit. Do we actually want it in pixel space? Or do we want it in like normalized space? Normalized seems easier to work with, right? Because like we can say that like if the mouse moved like 0.5 to the left, that kind of maps well to OpenGL space. So let's do that. So we'll say over rect height and over rect width, like this. And then here, I guess, this is gonna get pretty rough to deal with. So can we do something like const global state is a struct, and what's he gonna have in him? Can we actually do... Yeah, I'll do this. Global state, that's fine. So he's gonna have mouse pause, mouse down pause. I guess is gonna be like... We'll call this mouse down X. And he's gonna be like an optional float through 2 is equal to null. Mouse down Y. I guess we can just kind of like set these... Like, they don't need to be nullable, to be honest. Because we can also just say mouse down is a bool. Okay, so we're just going to say now that our global mouse down is equal to true. Our X position is X pix, and our Y position is Y pix. Okay. Now, we'll just make sure that everything compiles, and holy shit, our compile times are fast now. Hell yes, hell yes. Okay, on mouse move. We are going to give kind of like the same shit. You want normalized surely because the map size could change, the window size could change, right? Yeah, I agree. I agree. I agree. So here we actually want to say this is X norm and Y norm. Just to be clear. Then this is mouse move, and we have X norm, Y norm. Okay. And now we're going to basically say that the offset, we're going to like move, we're going to say that like our like lat center is going to be whatever we set it to down here. So lat center is starts at this, right? And the lawn center starts at this. There we go. Then we are basically going to adjust this by some like scale value times the difference in our X and Y. So we're gonna have to figure that out. But for now, let's start here by saying that this uses a global lat center and global lawn center. And we actually want to separate like our initialization from our render loop. So here we're gonna kind of do all this stuff here. And now our program and our array object need to end up in like global state as well. Bear from Mars, thanks for the prime, appreciate it. So this is a program pointer, i32 is equal to 0. We have the val is a also i32 equals 0. And then here we just say global program and global val. Then down here, we can bind the vertex array object like this. We can bind the program like this. Like this and like this. In fact, we actually want the uniform locations to be initialized one time because we had that problem where basically looking these uniform locations is going to leak some memory if we do it more than one time. So we'll say lat center lock is an i32 equals 0. Lawn center lock. Then these get assigned to global lat center lock and global lawn center lock. Okay. Now, here we can use those down here. Okay. All right. And here, I guess we need to do this again. Boom. Okay. Okay. All is good. And we'll call this render now instead of run. And I guess our like mouse move handler is going to ask for a re-render. That's kind of the way that this makes sense. So here he's going to say like mod instance exports render. And we probably have to render this once here. Now, how are we getting the canvas data out? What the fuck? Oh, because it's WebGL. So we don't actually have to like copy paste anything out of WebAssembly memory. It's just like rendering directly. Right. We're just like WebGL rendering directly. So that's fine. Okay. So in fact, here we could actually, we don't even have to go back into JavaScript land to do that. We can just say here on mouse move render. Sure. Okay. So now the only thing here is that we're gonna have to actually move the lat center along center. So we'll say global lat center plus equals x norm times scale. I don't know like how much it should be, so we'll figure that out. And this isn't just y norm. This is x norm minus global mouse down x like this, and this is minus global mouse down y. There we go. And const scale will just set to like 0.01 or something. Eventually we'll have to find some way to like actually figure out the latitude and longitude of where the mouse goes down, but for now let's kind of start here. There's a chance. So here it looks like it's just fucked off RIT. Draw arrays instance current program is not linked. Okay, so why? Oh, we never called init. That would do it. That would do it. We do have to initialize the things we want to initialize. It is true. It is true. This is out of range. Oh, because we can't init until we've already fed the data. This has to go down here. I remember. Okay, so now, are we still full of warnings? Yeah, wait, hold on. So it's good until I set the mouse over it. Then it's fucked. So this on mouse move is because it's not leaving. Here we need to say if global mouse down. If the mouse is not down, get the fuck out of here. Dude, this is okay, it's fucked. Scale equals this, right? Like this. In fact, let's just make the scale 0 to make sure that like, okay, re-render is still fucked whether or not the scale is set correctly, which is not good. Not good. Let's just try that. So here, if I move the mouse, if we re-render from there at all, it's getting through this clear correctly, But this stuff isn't working correctly, which is really surprising to me. Like, quite surprising. Do we have our log WASM thing available? Which still we do. So let's make like a little print function. It says like comp time format is a slice of U8s. The args are any type. And this is going to be like stud format buff print into some buffer, the format and the args. The slice is equal to this, and we log WASM the slice. And we just need some buffer to log into. So we're just going to say like var buff is a bunch of U8s. And here we're going to say, if we fail, we fucking crash. Fuck it. At least down here now we can say, we can like just look and see like map data F32. Can we like look at his like length at the very least and see if it's like reasonable? I think it should be, but I just don't understand why else like this would be having a problem. So yeah, the map data is still like totally valid. Can we print like the first 10 elements? So like 0, 10, like let's just see, like we're not like corrupting the memory, are we? Seems like it's very consistent, so that's fine as well. So it's what the fuck is going on? It must be related to this. Let's not change. Thinking. It could be that the like latitude and longitude centers are moving for some fucking reason, even though they shouldn't. We could take a look at that. Lat center is a number that is global lat center. And lon center is lon center. Lat center is not a number. Why? Can we like... Did I just fuck something up like heavy here? So here nothing's happened. So it's related to this like plus equals here. It's this. Like... Width spelling? Oh, I do fuck that up all the time, huh? Oh, fuck off. Thank you. We would have got there, but also fuck JavaScript, man. What a fucking shit-ass language, man. Seriously, what a garbage fucking language. That's so stupid. Okay. Okay, so that is working. It's like at the wrong... Definitely the wrong scale, so let's try going up by like 100 times. Oh, and we also don't want to change. We have to say that the... Basically, every time we do this, we have to reset the mouse down location. Because the next iteration of this needs to apply relative to that position. So I think that makes sense. We can only like do this. That feels like pretty good. Can we like up the scale some more? Yeah, it's going backwards. Backwards. So we're on the wrong axes. So we'll say lon here, lat here. And it's a little bit off, but that's plenty good enough. So we just have to make sure that we like basically on mouse up, say fuck you mouse position. Global mouse down equals false. There you go. Okay. Seems like we should be good. All right. That problem solved to some extent. So we'll call that add pan. Add pan complete. Let's add some zoom. Tipaget, thanks for the prime. Much appreciated. You guys have it so easy with your type languages. It's so easy. JavaScript requires that you are a real developer. That's a really funny take. Okay. Okay. So now we want to do zoom. So we need to like scroll. Scroll, please. Why am I just Googling the word scroll like a fucking dumbass? On scroll. Uh, on scroll. On scroll. Okay, so let's just kind of like, what the fuck is this thing? Okay. So that's not good. How do I make it so that the scroll doesn't happen? I guess here we probably set the canvas to fill the width and height of the page so that scrolling doesn't do anything. Okay. Hello? That's not 100%. Am I fucking stupid? Oh, I see. So the canvas needs to have pixel space match. God damn it. Canvas, fill, screen, HTML. Do I have to do it in JavaScript? Yeah, okay. So I have to, so this guy's basically saying that I have to set the properties so that the pixels match the size of the screen. And then here I set my body to fill the fucking screen. Okay, so I guess here just, we're not gonna handle resize because fuck you. We are just gonna here just say, canvas width is equal to window, canvas client width. No. Yes. Yeah, maybe? I'm not 100% sure on this, but we can try it. We can always try it. Nope. Obviously not. Obviously not. I don't really want... Maybe VW and V8 units will work. I mean, I think it's more that the canvas width and height need to, like, match in pixel space and, like, window space. I think. If I understand correctly, sometimes you set body... Yeah, you're right. I did forget to set the style parameters here. So what we do, like, body width is equal to 100% and is it semicolon? I can never remember. Okay, so here our body fills, our canvas does not fill, but width 100%. Okay, wait, can we go back here to like 100%? Is that okay? No. Somebody else is saying that you can use VW and VH or something. I've never heard of these before. But I don't think this is going to do it either. I think that what I have to do here is I have to set the style width and height to be 100%, 100%. And then set the width and height and pixel space in HTML. You're saying I can do this. Yeah, I think that's just interpreting this as pixels. I think that it's just interpreting this as pixels, so fuck it. We'll just do JavaScript. So here we'll just say that yeah, that should be fine. There we go. Why is height not what I want? What am I doing wrong here? width height 100%, body width height 100%. Shouldn't this like shouldn't height 100%? Height 100% not working. Needs add on resize, but even when it's not being resized, HTML height equals 100%. Like really? 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 We'll see. But like I understand like on resize it's broken, but there we go. Okay, that's what I was looking for. That is what I was looking for. Close enough. I mean, now I need to disable the padding and shit as well. But this is good enough for now. Okay, how do I like oh, I guess here I need to be a little careful because I can't have it like get too big. So we'll just do 90 and 90 and then call it a day there. Cool. Why is there still scrolling? Because oh my god. Like is it like this? I just want to make sure that I like don't like fucking run over the fucking edge of the world, you know? There we go. Okay, now there should be no scrolling. Good. And I need to figure out how to zoom in and out on this map now. This can be like 95. This should be 100 here, I guess. I don't fucking know, man. I don't know. Okay. Okay. Good enough. Okay, so how now I need to make sure that like I can like on scroll on this thing. So why am I seeing scroll events now that the scroll events aren't covered by the other shit? No. Which is annoying. Because I have canvas on scroll. And why am I not seeing it? On scroll not triggering. There's some other logs that I'm trying to get rid of here. So print here. Here we go. Get rid of the fuck out of these things. On scroll not firing. JavaScript. Oh, is it only on window? Sure. That's fine by me. Sure. Maybe it is just window. It's a little silly, but I don't really care right now. I just want to get like something because this is not what I care about at the moment. I really don't give a shit. Like, is this firing now? Console? No. Is it on mouse wheel or something? Is that why I'm like, it's the fucking... Okay. Scroll isn't necessarily triggered by a wheel event. Elements can also be scrolled using the keyboard. Wheel doesn't necessarily dispatch a scroll. Okay, I do just want wheel. Can I do like canvas wheel now instead of window wheel? Canvas on wheel. Log the event. Let's see it, baby. There we go. Okay, and so what happens on this guy? So I see delta Y probably is what I'm looking for. Probably. So mod instance exports zoom ev delta Y. And in here somewhere we set a zoom function. Which takes in delta Y, which is in some fucking arbitrary unit. Who knows what the unit is? Who fucking knows? But it is something that goes like negative number to number. And wavy. Let's see if there's anything else in here that yeah, okay, sure. So we need some function that basically maps like negative number to number smaller than 1, positive number bigger than 1. And maybe what we'll do, instead of doing anything sane, is we'll just say if delta y is less than 0, else if delta y is greater than 0. Guys, we'll do better later, okay? We're just trying to get something, okay? Okay, we'll chill the fuck out, chill the fuck out. Global zoom times equals 0.5, and here global zoom times equals 2.0. Okay, 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 sure. Zoom 1.0. Okay, okay. So now all of this was just we could see the fucking roads. That's all we fucking wanted. That's all we wanted. We need to set a zoom lock to global zoom, and in our vertex shader, now we can say that we have a zoom thing, and then when we, initialize our program, we need to look for the zoom location, of course. So this gets looked for with zoom, lock, key, pointer, and length, which means that here we need to like make a constant from somewhere for the zoom, lock, key, of course. Cool. And then in all of this stuff, in our vertex shader, now we just take the zoom position. So for our y, we just multiply this by 10 times zoom, and this times 5 times zoom. And maybe that's fine. What's this subtraction for? It's because this is for the top left, probably. We were probably looking at the top left into the center, so I'm just gonna... I don't think these should be here. Right, because if this is where we expect the center to be... Yeah, seems fine. Why is this minus and this plus? That's a little weird. Probably this is supposed to be negative. Whatever, this is probably going to be fine for now. This is going to be enough, right? We don't have to get too crazy. What is it mad at? It's mad that I used a fucking semicolon here. Oh my god. Oh my god. No field name zoom lock. Fine. If you fucking need a field there, I'll fucking put the field there. Okay, so now that's no good because probably we initialize our zoom level to 0 and it should be initialized to 1, which it is. Okay, so maybe it's this stuff's important. Does seem important. Zooming does nothing. Oh, fuck. Wait. Oh, it's because every time I zoom, I have to re-render as well. Of course, we have to render. Is this ExpoGL? I don't know. Probably not. So now we're not zooming relative to the center, which is kind of what I expected. Does seem like maybe we just apply, like, we're doing something stupid here with our position offsets because we just kind of like copy pasted what we had last stream. Let's maybe look at our metadata here says that the midpoint should be like 49.2 and our midpoint should be like 49.2 negative 123, right? So center, right? Whatever the fuck we're doing here is just stupid. So hand wavy. Where the fuck are we? We want to go into Zig. Why don't you use affine transformations? Why don't you shut up? Sorry, that was rude. Why would, like, there's no reason to, right? Like, I can just, I don't know, I'm just doing what makes sense to me. Ouch. Yeah, that was a little harsh. It was a little harsh. I'll give you that. So what was it? We were in like metadata. Here. So this is negative 122 ish. Negative 122. Oh, it's negative 123 ish. So if both of these are being added, these should both be minus to get them into the 0 range. Then this shit should go away, probably. This feels like how the math should work to me now. So we like center where we want the center to be, and then we scale everything around that by the zoom level. Yeah. That seems reasonable to me. It seems reasonable to me. Probably what's going to happen here, though, is I'm going to refresh, and it's going to be wrong. Why is this rerunning the fucking map data processing? I didn't change any of that. Okay, whatever. We'll live with it. File not found. Am I fucking... Oh, I'm in the wrong folder. Oh, which is probably why it re-ran that shit, is because it was in a folder relative to where we were. Okay, there we go. Our directions are backwards again after that scaling, but there we go. That's moving and grooving. Definitely moving and grooving. Okay. So our lat center and lawn center movements have to be inverted. And then also the zoom level feels like it has to be inverted. So we'll do this. And then also, I think I want to basically scale the amount that we move by the zoom level. That feels right. Maybe divide by the zoom level. If we're zoomed in a lot, we want to move less. So now scrolling up, move this in. Vertical is right, horizontal is wrong. So we need to change the vertical. It should be, I guess, plus here. Okay. There we go. And it does kind of feel like the amount that we're moving is the same. It does feel like the scale needs to increase here, just a tad. So maybe we like double this. There we go. That feels decent. That feels good enough. So all of this work was just so that we could zoom in here and look at how fucked it is. All of that was just so that we could go in here and be like, wow, it is bad. But because we spent so fucking long on compile speed stuff, I think that we are kind of at a point where it makes sense to call it, right? We kind of, what do we do today? We fixed, we added pan and zoom, but most of our time was spent on compile speed problems. So before we were baking in all of the vertex data directly into our Zig code, that meant that every time we modified anything in Zig, we had to recompile, we had to reparse this like giant list. We tried making it JSON. That JSON was like fucking 125 megs or something, 150 megs. It was way too large. So we squashed that down to binary data. We, in JavaScript, pull that data chunk by chunk into WebAssembly memory, and then in WebAssembly, then we just can say, okay, we have these 32-bit floats. There you go, buddy. We probably could have done that all in JavaScript, but whatever, doesn't fucking matter. Yeah, we're looking pretty good. Next is fill in the pixels with interpolation. No, what we're actually going to do is we have a bunch of like node data of like how these things are supposed to be attached, and so the next thing we're going to do is we're going to be doing like line rendering of these things. So that's for tomorrow. And I think good, decent progress for today. I would have wanted to get farther, but we got kind of we had some fun on like data transfers. So fuck it, you know. Yeah, okay. Cool, guys. So thanks for watching. If you're new here, we stream most days at around 2 o'clock Pacific time for what we call like the main stream. We do like kind of like a 12:30 start, and in that 12:30 to 2 section, it's kind of more like it's less like trying to make like focused progress on a feature, but more like cleanup of other stuff, like side features that aren't really that important, things that don't map cleanly to a YouTube video. Those things kind of we do like a pre-stream for those. There's a YouTube link in the Twitch description where you can see all of our previous projects kind of grouped in playlists. So if you want to check out things that we've worked on before, there's like an operating system, there's like a terminal emulator, there's like a QR code decoder, a video editor. There's stuff in there if you want to check it out. GitHub link in the Twitch description as well. For code for this stuff will end up under the SFMAP repo. So that'll go up soon. What else? We have to plug the typical stuff where we ask for likes and subscribes and Twitch primes and Patreon subs and all that stuff. So if you feel inclined to do that, that's all there. Follows as well, blah, blah, blah. Otherwise, I think that's all we got to plug. I would like to say goodbye to YouTube viewers and Twitch. Let's find someone to raid.